Antonio Project presents Dry Inner Gas Generator Part 2.
Hello everyone, welcome back to my channel. After learning about dry inner gas generator, parts name and its functions, let's continue to learn about how dry inner gas generator work. On board the gas tankers, safety is more than a procedure. It is a commitment built into every system. Among the system, the dry type inner gas generator plays a crucial role in protecting cargo tank from explosive atmosphere. Unlike conventional flue gas system used on oil tankers, the dry type inner gas generator is designed specifically for gas carrier, where clean, dry, and precisely controlled inner gas is essential. In this video, we'll explore how the dry inner gas generator works, from fuel combustion and gas conditioning to final supply to the cargo tanks. We will also look at the safety feature, oxygen monitoring, and system check that ensure reliable and continuous inerting during gas handling operation. Join us as we step inside the heart of gas tanker safety, the dry type inner gas generator part 2. Let's go!
Inner Gas Generator Operating Mode. The inner gas generator can run in different modes to fill the cargo tanks with inner gas, dry air, or wet air. The mode can be changed by turns gauge selector switch on the IGG operation panel. The modes are as follows. 3. Wet air mode. In wet air mode, the inner gas system produces air with a normal oxygen content of about 21% and very high humidity. Wet air is breathable for humans without the need for breathing masks. To produce wet air, the inner gas system bypasses the dryer. Ambient air blows through the scrubber tower and the cooler before it is delivered to deck and therefore produces a lot of moisture in the piping and cargo tanks. It is not recommended to use wet air mode for gas tankers. Two, dry air mode. In dry air mode, the inner gas system produces air with a normal oxygen content of about 21%, but with almost no moisture in it. Dry air expels the toxic inner gas from the cargo tanks and dries the piping and tanks. To produce dry air, ambient air is blown through the system in the same way as when producing inner gas, but without burning fuel oil. One, dry inner gas. In inner gas mode, the inner gas system produces inner gas by burning a mixture of air and fuel oil and treated to obtain the required properties. The properties of dry inner gas are as follows. A. The combustion process system itself must not produce any soot because soot is harmful to the inner gas and the ship's piping and cargo tanks. B. The inner gas must contain no more than 1% oxygen or O2. C. The inner gas must be dry. It must contain as little moisture as possible to prevent ice in the ship's piping and cargo tanks. Capacity selection. To select the number of combustion blower to be used, there are three capacities. 1. 50% load for IGG blower number 1. 2. 50% load for IGG blower number 2. And 3. 100% load for both of IGG blower. Line up and start seawater cooling unit. Here is how the inner gas generator works in the dry inner gas mode process animation. The process started by line up and supplying seawater. Confirm the seawater supply valves and seawater overboard valves under open position. The seawater supplied by the cooling seawater pump is taken from the sea chest, then flow to the scrubber unit, where the seawater will be divided into several branches that act as cooling medium and also as a medium for washing inner gas. The combustion chamber is surrounded by a cooling water jacket to discharge the generated heat as much as possible. The cooling water jacket is provided with a spiral, so the cooling water flows around the combustion chamber wall and an optimal cooling effect is achieved. Seawater is channeled directly to the sprayer in the combustion chamber and to the spray pipe in the scrubber. Then, through the seawater control valve and two orifices, it is directed to the combustion chamber jacket and the front of the burner. The seawater leaving the sprayers flows out via the water regulating valve, and the cooling water leaving the jacket is discharged directly to overboard. Line up and start chiller and cooler unit. The IgG cooler unit connected to chiller unit to the evaporator side by piping system filled with mixture of glycol and water. The glycol water mixture circulates in a closed loop between the heat exchanger of the cooler and the evaporator of the chiller by using glycol circulating pump. The chiller condenser cooled by means of freshwater cooling, usually from central cooling freshwater system. Before startup chiller unit, it is necessary to line up the freshwater cooling system. Glycol circulating pump to be started 1 or 2 minutes before starting chiller compressor. It is to make sure that the glycol water circulates in closed loop from evaporator to the cooler pipeline. Then start chiller compressor. The compressor compresses a refrigerant gas. This gas then condensed in the condenser to a liquid state, that is, injected into the evaporator. During evaporation, much heat from the glycol water mixture that passes the evaporator is absorbed by the refrigerant. Please hit bell button, click like, and subscribe to my channel. Line up and start dryer unit. Next is to prepare the ADS dryer and make sure the valves related to the drying operation are in the open position. By pressing dryer start button, the dryer unit is under standby condition and the valves related to the inner gas drying operation will be open. Inlet valve to dryer. Outlet valve from dryer. Purge valve to atmosphere. Start IGG under dry inner gas mode. To start IgG in inner gas mode, the mode selection is set to number 1 dry inner gas. Then press the generator start button. The sequence will start from the two-state IgG blower running to the ignition of the pilot burner. The main burner will catch the pilot flame, then fire on. There are 3 steps to produce dry inner gas from the combustion gas, namely 1. Cooling process, 2. Condensation process, 3. Absorption process. The cooling process takes place in the scrubber tower. The gas is sprayed by seawater, so that the gas temperature decreases and turns into saturated inner gas. To remove water from saturated inner gas, the inner gas system uses condensation and absorption processes. The condensation process takes place in the IgG cooler unit, and the absorption process takes place in the ADS dryer unit. The final pressure required by the plant is achieved by 2 multi-state type air blowers. This pressure is kept constant to ensure a stable flame during operation, regardless of pressure fluctuation in the distribution system. This is done with a pressure control valve at the end of the installation. A good combustion process is the first requirement for a reliable inner gas generator. The operating sequence of the inner gas generator begins with the operation of the two-state IgG blower one by one. Ambient air is fed into the combustion chamber as a source for producing fire. With steam supplied under pressure to the burner, the fuel oil is atomized in such a way that perfect mixing of fuel and air is achieved, so that the flame behavior is identical to the gas-air mixture. To achieve the required low oxygen content without soot formation, the inner gas system has a combustion chamber with a highly effective burner. As a result, a bright blue flame is seen, which, even at zero oxygen content, does not produce soot. This soot cannot be tolerated in the plant, neither in the ship's cargo tanks nor in the piping system. To prevent it, especially in long term, is only possible in very stable and balanced combustion process. Pilot burner provides a small flame to ignite the main burner. Pilot burner fuel valve opens to supply fuel to the pilot burner. Additionally, compressed air injected to atomize pilot fuel. Simultaneously, a spark igniter creates a spark. The pilot flame is monitored by a flame scanner. If the flame is not detected within a few seconds, the system shuts down for safety. Main fuel using low sulfur diesel oil is admitted after the pilot flame is confirmed. Using atomizing steam, the fuel being atomized and mixed with heated ambient air from IgG blower. The pilot flame ignites the atomized fuel-air mixture and generates the main flame in combustion chamber. The combustion is a chemical reaction between the hydrocarbon and the oxygen, mainly producing carbon dioxide and water. The water is condensed for the greater part. The nitrogen of the air leaves the generator unchanged. Some small rest quantities of carbon monoxide and hydrogen may remain. Thus, the inner gas produced mainly consists of nitrogen and CO2. The hot combustion gases are cooled, first indirectly in the combustion chamber by a seawater-cooled jacket. The principal cooling, however, occurs afterwards in the cooling section. When the inner gas leaves the combustion chamber, it enters the washing tower or scrubber tower, where it is sprayed with seawater. It passes a curtain of seawater to lower the temperature of the gas and to wash out the sulfur oxide. Because of the intense contact between inner gas and seawater in this cooling tower, the inner gas temperature is decreased close to the seawater temperature, while corrosive sulfur oxide are washed out of the inner gas. The inner gas is now 100% saturated instead of dry. As the gas rises up in the scrubber tower, it passes a demister. The demister is a wire mesh that separates the bigger water droplets from the gas. Condensation process. Inside cooler unit heat exchanger, a mixture of fresh water and ethylene glycol with a temperature of about 1 degree Celsius cools down the gas that passes through the tube to below 5 degrees Celsius. When the gas cools, the water condenses and separates from the gas in the demister tower. This removes 99.9% of the droplets of 5 microns and above from the gas. Then, the condensate water is discharged overboard. Oxygen analyzer. An oxygen analyzer is installed to allow continuous monitoring of the oxygen content and indicates the oxygen content in the inner gas. This oxygen analyzer will sound an alarm if the set maximum or minimum oxygen levels are exceeded while the inner gas plant is in use. This type of inner gas generator having ability to produce inner gas with an oxygen content of only 0.5% instead of 1%. When the gas leaves the cooler, most of the moisture is removed by condensation. The inner gas temperature reduced to few degrees above freezing point. However, the dew point is still above 0 degrees Celsius. Absorption process. After the condensation process in the cooler, the inner gas enters the next process, namely the absorption process. To reach the correct dew point of minus 45 degrees Celsius, the gas flows through a dryer vessel from top to bottom. The dryer consists of two dryer vessels that are filled with small activated alumina beads. This filling material functions as a desiccant that absorbs the water vapor from the gas. The two vessels of the dryer work in alternation. While one vessel is drying the gas that passes through it, the other vessel is being regenerated. Adsorption is a surface phenomenon where atoms, ions, or molecules from a gas, liquid, or dissolved solid adhere to the surface of a solid or liquid, called the absorbent. It is different from absorption, where the substance is taken up into the volume or bulk of the material. The key difference between adsorption and absorption lies in where the substance accumulates. Supplying inner gas to cargo tank. It took several minutes before the inner gas could be delivered into cargo tanks. The inner gas is continuously monitored to meet the following criteria. 1. The oxygen contents below 1%. 2. Dew point is below minus 30 degrees Celsius. 3. Temperature is safe. 4. Flow and pressure are stable. 5. All safety interlocks and alarms are active. Before the inner gas condition meets those criteria, the inner gas being discharged to atmosphere through purge valve. During a drying cycle, the dryer vessel absorbs the moisture from the gas, inner gas or air, that flows through the vessels. During a regeneration cycle, the dryer vessel is being prepared for its next drying cycle. While one dryer vessel is drying, the other vessel is regenerating. The drying cycle and the regeneration cycle each take 6 hours. When both vessels have reached their total cycle time, the vessels switch over. I will discuss this drying and regeneration cycle in another video. After compound IgG system running normal and dew point reach below minus 30 degrees Celsius, push button standby for delivery start flickering. By pushing the button of standby for delivery start, the flickering is stopped and the dry inert gas can be supplied to cargo tank. The inert gas delivery valve can be operated from cargo control room monitoring system. When delivery start button pressed, valve for delivery line is open and purge line is closed. There are two sets of non-return swing check valve fitted for the gas tanker's inner gas system. This is to avoid moisture caused by the type of water seal usually installed in wet type IgG to ensure the inner gas produced is dry. The inner gas line is connected to the vapor line and liquid line by means of removable spool piece. In the normal cargo operation, this spool piece is disconnected to avoid misoperation. By selective use of the spool pieces, it is possible to inert or aerate all or just a single cargo tank. The inert or aeration process to the cargo tank can be supplied from bottom side or bottom feed using liquid line or from top side or top feed using vapor line, depending on the required method. There are two primary methods are used to inert cargo tanks. One, displacement method. Inner gas is introduced slowly and rotated to the bottom of the tank. 2. Dilution method. Inner gas is introduced from the top of the tank at high velocity to sweep the atmosphere effectively.
I think that's all my video. We just explored the full operation of the dry type inner gas generator from combustion and gas conditioning to the critical safety checks before inerting cargo tanks. On board gas tanker where even a trace of oxygen or moisture can pose a serious hazards. Dry inner gas system provide a reliable barrier not only for fire and explosion but also against damage to the cargo. Proper understanding, regular maintenance, and precise monitoring are key to ensuring the system perform as intended, safely and efficiently. Thank you for watching my video. I do hope this video has enhanced your knowledge of one of the most important safety system in modern gas tanker operation. Stay alert, stay safe, and see you in my another video. Bye bye.
If you enjoyed this video, please give it a thumbs up and don't forget to subscribe to my channel for more maritime engineering and safety contents. Your support helps me to create more valuable videos for seafarers, engineers, and maritime professionals around the world. Until next time, sail safe, stay sharp, and keep learning. Bye-bye.
Thank you for watching my video. Terima kasih di Antonio Project.